channel. I am Kirti Reddy from Sri Venkateshwara College of Engineering. I am currently pursuing my computer science and engineering at Sri Venkateshwara College of Engineering. So today's topic is under the subject data structures and application. The topic is exploring variational data structure, a choice of variational stacks. This presentation is based on a research paper. So let's dive into what variational data structures are and how they can help in data handling variability in data and software systems. Introduction. So to begin, let's talk about variability software system in data computation. Many software systems allow users to configure different options, creating variability. This variability is also common when analyzing data, where small input changes can lead to different results. The challenge here is to represent and compute these variations efficiently. Variational data structures are essential for this. The goal for this presentation is to understand different designs of variational stacks and the trade-offs involved in their performance. So what are variational data structures? Variational data structures are a way to represent many different versions of data in a compact form. For instance, when handling multiple software configurations, we can represent all the options at once instead of handling them individually. One of the main concepts used to express this is called choice calculus, which allows us to work with different variations in data effectively. So, variability aware execution. The goal is to combine multiple execution paths into one, making software testing more efficient. Instead of testing every possible configuration individually, we can share common operations between different configurations. This is especially important in systems like Java, where the operand stack plays a crucial role. The variability-aware Java interpreter uses variational stacks to manage this efficiently, and that's where variational stacks become a key data structure. Choice of stacks. One way to implement a variational stack is through a choice of stack approach. In this design, we represent variation data as a choice among multiple non-variational stacks. Each stack could have a different number of different elements depending on the configuration. This design handles unbalanced stacks naturally, but the downside is that common values need to be duplicated across stacks, which can take up the memory and time. Stack of choices. Another design option is stack of choices. In this approach, instead of creating separate stacks for each variation, we use a single stack with conditional values or choices within the stack. This allows us to avoid redundancy by sharing values between configurations. However, design is more complex, especially for operations like pop, where we have to manage that we call holes or null values in the stack when variations don't apply. Optimizations, buffered and hybrid stacks. To further improve performance, we have two optimizations, the buffered stack and the hybrid stack. The buffered stack keeps track of push and pop operations in a buffer as long as the context remains the same, reducing the need to interact with the variational stack. The hybrid stack, on the other hand, starts as a plain stack and switches to a variational stack when variation is necessary. This optimization can significantly reduce the time and memory required for stack operations. Experimental analysis. Now let's look at the experiments. In the first experiment, we analyzed how different variational stack design perform as we increase the number of configuration operation The stack of choices implementation performed better when there were more configuration options. Thanks to this ability to share values across configuration. In the second experiment, we focused on how well stacks handle sequential operations in the same context. Here, the buffered stack optimization proved to be very effective, especially with the choice of stacks design. Variational stacks and applications. Next, the researchers tested the variational stack in real-world application using a VarexJ interpreter. They evaluated four systems: email, evaluator, ZipMe, and GPL. In all the systems, the stack of choices implementation outperformed the choice of stacks design. Additionally, the hybrid and buffered optimization greatly improved performance, reducing the runtime and memory across all systems. To wrap up, choosing the right variational stack design can have a major impact on performance when dealing with variability in data and code. This stack of choices design is generally more effective and for large configuration spaces and hybrid and buffered optimization. Thank you for watching. I hope this gave you a clear understanding. The stack of choices design is generally more efficient and large configuration spaces, and the hybrid and buffer optimization provides significant performance gains in real world application. So looking forward, there's still more to explore in terms of how these stacks perform in different scenarios. Thank you for watching. I hope this gave you a clearer understanding of variational stacks and their importance in computing with